So we looked at percents and all that, and the ratio and proportion, and the measurement. And the big thing I want to talk about today is I want to review those percents a little bit and make sure we understand how they work. And then I want to get into how that starts to apply to some of our medical stuff. So I just want to review some different types of percents. When we have a relationship, if we have these relationships, they're being represented by a whole amount and then pieces within that whole amount. And they may or may not overlap. For example, let's say I have 100 marbles in a box. The only reason I'm using 100 is because a percent is out of 100. If out of those marbles, if 40 of them are blue and 60 of them are red, we have a couple of different percents represented here. If I want to know, if I want to describe the blue marbles, that's 40 out of 100, or 40%. Even if I didn't know the total was 100 and I didn't know how many red marbles there were, if I knew that the whole amount, all 100 marbles, was made up of either red or blue marbles, I would know that 60% had to be red. And this is something we call complements. So complements are two possibilities two things that make up all possibilities. Make up all possible results. And that's kind of a statistics term, the complement, but it happens a lot in math as well, where there are only two possibilities, or everything within a group fits one of two categories. That doesn't mean there aren't other categories, but we classify them in one or two categories. If I go out and survey people in the city, I could classify people. I'm only looking at a certain thing, a certain characteristic. I can classify them as people who are students and people who are not students. I classify them as people who work from home or people who leave the home to work. That one's not necessarily the greatest thing, but you understand what I'm saying? People who leave the home to work and people who don't leave the home to work would be probably the easiest way to do it. So I can make the classifications so that they fit that way. And a lot of what we work with in math is just like that. They are either in one group or another. So let's say that I'm talking about students here, and just for this class, if I looked at enrollments, if I said that 75% of the enrollment in this class is over the network, over the ITV, what percent is in the classroom with me? 25%. Those are complements. If they're not on the network, you have to be in the classroom. That's the only two possibilities. And there are always those 3% present. 75% or 75 out of 100 is on the network. ITV to be lazy. The complement of that 100 minus 75 was 25 out of 100 is in the classroom. And then we also have that third percent that's always working there, the 100% that represents total students, everybody. Now, aside from percents, Percents are a specialized form of a ratio. And ratios have that same relationship. Let's say that I am going to mix 4 parts of a powder with 6 parts water. I have actually created several different ratios here. We have 2 types of ratios that we look at. One is the type that we worded out of, where we're saying a part compared to the whole thing. Now in this case, this part is actually included within the whole, but we're focusing in on a part of it. So like for this class, there are 4 students in the classroom, 12 students on the network, but there's 16 total students. So I might say the ratio of students in the classroom to the whole class is 4 out of 16. The 4 that are in the classroom with me are included in that 16, but I'm focusing in on that group. Or the other way around. I could say on the network, there's 12 students on the network out of 16 total. So again, the 12 are included in the 16, but I'm focusing on them for some reason. Or I could have the 2, or the compared to type of ratio. This is where I have 1 part compared to its complement, or another part. So for this class, I might say there is a 12 to 4, or 3 to 1 if I wanted to reduce it, ratio of students on the network compared to students in the classroom. So neither group is included in the other. I'm comparing 2 pieces to each other rather than 1 piece to the whole amount. So for my example up here, if I'm comparing 4 parts of powder to 2 parts water, there are 2 types of ratio created here for that out of ratio. I could have 4 parts for the powder. Here. 4 parts to total parts. How many total parts would there be? 10, right? 4 plus 6. So the ratio of powder to total is 4 out of 10. Or I could create the ratio of water to total, which would be 6 out of 10. On the other side of things, I could have my ratio of, I'm going to put it down here so I got more room. Powder to water, which would be 4 to 6, right? 4 parts of powder to 6 parts water. Or I could have water to powder, which would be 6 to 4. Those 2 ratios are kind of interchangeable because there's no application where one would work and the other one wouldn't. Any application where one of these 2 would work, the other one would. The difference is, of course, these 2 ratios both will work differently for different types of problems depending on what we know. And then, of course, where we'd use one of these would be a different type of problem. So why is this important to the medical fields? Well, when we're looking at concentrations, which we're going to talk a lot about here over the next couple of weeks, concentrations are talking about parts of a medication, and I'm going to use the generic word serum. For this class, the term serum refers to any sort of medication or a concentrate. So it might not be pure medication, it might be the more concentrated, the higher concentration of the medication. So the concentration is the parts of the serum to total parts. And this is always, almost always converted into a percent. Or sometimes expressed as a rate. When we did our mixture word problems, our mixture calculations, we had to change that percent into a rate, a decimal, and use it that way. So that percent or rate is our concentration. Now with the algebra we've learned, we can move that around. What we used for those mixture problems was we multiplied both sides by total parts, and we got the parts of the serum, or the amount of the serum, is equal to that concentration times the total parts. Same formula, just adjusted around a little bit. Another major application in medicine for us is something called the dilution. And we're going to talk a considerable amount about dilutions. A dilution is one of two things. Either you are taking a pure medication, pure serum, and you are diluting it into a fluid that is non-medicinal, no medicinal value. Stretched me to the limit of my spelling capacity there. Sorry about that. So a pure medication into a non-medicinal fluid. The terminology we would use for this, we would use serum for pure medication. Our non-medicinal fluid, we're going to use the abbreviation NS. NS can stand for a couple of different things. It can stand for normal saline, which is just a pH-balanced saline fluid. Basically, it's water that's pH balanced to match the pH of your body. Could be neutral solution. I'll write these down. Normal saline, neutral solution, which again, it just means some sort of solution has no medicinal value. It's just a carrier to dissolve the medication into it and take it into the body, but it's not going to add anything to the medication other than a vehicle to get it into the patient. Or just sterile water. Sterile water is just a medical grade fluid for dissolving the medication. It may or may not. The only difference between sterile water and normal saline is that sterile water may or may not be pH balanced, pH controlled. So anyway, that's one type of dilution. We're taking that pure medication and putting it into that fluid, the serum into the saline. The other type of dilution we can run into is we can have a concentrate. Now by concentrate, it is already a solution. It just has a higher concentration than what we desire. And we can dissolve it into that fluid again, NS. For the sake of simplicity, we're going to refer to that concentrate as serum in most cases as well. And all this is we're taking a medication that's already dissolved into a fluid at a higher concentration. We're lowering its concentration by dissolving it into more fluid. So the dilution is literally that. It is parts of the concentrate but it's not to our parts of fluid, it is to total parts. So if I have a 1 in 5 dilution, it's a 1 out of 5 ratio. The 1 represents the serum. That's either the pure medication or the concentrated solution that we're putting in. The 5 represents total solution. So now from this, with our discussion of complements, how many parts of sterile water were added to this? We have 5 total parts. One of those parts was serum, 4 parts. The rest would be sterile water. So this is saying there's 4 parts of NS here. So the other ratios that could be found here is we could have a 4 out of 5 ratio of our sterile water to total solution. Or the third ratio of importance is we could have a 1 to 4 ratio of serum to water, saline. Now you might look at that and say, well, why don't we do saline to serum? It's usually just, it's more interesting, more applicable, more often that we're looking at the serum into the saline, not the other way around. So if I tell you that we have a dilution of, let's say we have a 2 in 9 dilution. And I ask you, what is the ratio of serum to water, to saline? Well, I'm going to start out with my dilution. I have a 2 in 9 dilution. What does the 2 represent? Serum. What does the 9 represent? 9 represents total solution. So we want the ratio of serum to our normal saline. So the serum can stay as a 2. That's 2 parts. How many parts of normal saline do we have? 7. 9 minus 2 makes 7. It's the complement. Whatever isn't serum has to be saline. If, let's see, we have a 3 in 10 dilution, find the ratio of saline to total solution. So again, I'm going to write down my dilution, 3 in 10 dilution. The 3 represents serum. The 10 represents total solution. So I want the ratio of saline to total. So the 10 can stay. That's my total. But I want the saline up here. How many parts is that going to be? 7. Again, 3 out of the 10 are serum, the other 7 must be saline. So where does this number come from? 3 in 10 dilution, 1 in 6 dilution. What does it mean? Where does it come from? What are we going to do with it? Well, let's say we are going to dilute 30 milligrams of medication into 80 milligrams of normal saline. What dilution have we created here? Now, you have to be careful. We're looking at dilution. A dilution is serum total parts. If I create my ratio here of 30 milligrams to 80 milligrams, I can reduce that. Of course, milligrams cancel out. I can divide out as 0, divide by 10, in other words, to give me a 3 to 8 ratio. But what is that 8, or what is that 3 representing? That comes from the 30 milligrams of serum. What is the 8 representing? It's the 80 milligrams of saline. Does that fit our dilution ratio? No. The 3-part serum does, but what's going to be on the bottom of that ratio? 11. Good. Total parts. The total is always serum plus saline. So if we add 200 micrograms of serum to 5 milligrams of saline. Actually, let's do this. Let me see. 5 milligrams of total solution. We'll make it simple on us here for now. So we add 200 micrograms of serum into a solution to create 5 milligrams of total solution. What is our dilution created here? Well, the dilution, of course, is serum to total. And we do have serum and total. The problem is, remember several weeks ago when we talked about ratios, what did we say had to be true about our ratios? Both numbers had to have same name, same units. These do not. So I have two choices. I can either convert the micrograms to milligrams, or I can convert the milligrams to micrograms. Either way, there's going to be some reducing and simplifying of my ratio that has to be done. Anybody have a preference? It's usually easier to go to the smaller unit and then reduce it down. So I will leave this as 200 micrograms here. Changing my 5 milligrams into micrograms. If I'm looking at my chart, milligrams to micrograms, or mcg instead of μg if you wanted to use that, is 3 spots to the right. In other words, there's 1,000 milligrams in 1 microgram. So if I move my decimal point over 3 spots to the right, I do have to add my zeros, which gives me 5,000 micrograms for the 5 milligrams. Now that I have the same units, I can reduce my ratio. The micrograms can disappear. 200 over 5,000 can both be divided by, well, they both end in 2 zeros, so I can divide both by 100. Gives me 2 over 50. Am I done? Not quite. Both of those can still be divided by 2 to give me 125. So that's 1 out of 25, which is telling me that this is a 1 in 25 dilution. Any questions on that? Obviously a really weak dilution there. if I give you that we have 80 milligrams of solution containing 70 milligrams of NS. Find the dilution. So again, dilution is always going to be serum to total. Let's look at what we have here. Well, the 80 milligrams is our total. So I can go on bottom. Oops. Can't lose a zero. The 70 milligrams, however, is not the serum. That is the saline. So if we have 80 milligrams total, 70 milligrams of saline, that leaves us with 10 milligrams of serum. Milligrams cancel out, both of those. 10 and 80 can be divided by 10. Give us a 1 in 8 dilution. Let's say a 2 in 5 dilution contains 40 milligrams of serum. How much saline does it contain? So 2 in 5 dilution. Again, 2 is serum. 5 is total solution. Now I could use that 2 out of 5 and get the total and work with it. But here, since I'm comparing serum and saline, it would be nicer if I had a ratio of serum to saline. Well, that ratio is going to be what? 2 to 3, yes. 2 parts serum, and if there's 5 total parts, 2 are serum, the other 3 are saline. So the ratio of serum to saline is 2 to 3. And now we can go to our proportions. The 40 milligrams represents the serum. So put 40 milligrams up here. Now we can cross, multiply, and divide. 3 times 40 milligrams is 120 milligrams. Divided by 2 gives us 60 milligrams of saline in that solution. A 1 in 6 dilution contains 200 milligrams of saline. What is the total milligrams of the solution? And that's sloppy wording. So 1 in 6 is our dilution. So the 1 is the serum, 6 is total. We are looking for the total, but we do not have the serum. We have saline. So what would be more useful for us would be a ratio of saline to total. What is that ratio going to be? Well, the total would stay 6. how much saline would there be? 5. If out of 6 parts, if 1 part serum, the other 5 are the saline. So we have that ratio of 5 to 6 of saline to total. 200 is the amount of saline. We can cross multiply and divide. 6 times 200 divided by 5 is 240 milligrams of total solution. There's all sorts of variations of this that we can go through, and we will go through more next week, and we'll actually start to look at some of the applications of this next week. For right now, we're going to call it a good week. If you need to finish up the test, please feel free to stick around as long as you need to finish that up. For next week, we didn't get far enough to give you a homework assignment yet, so we won't have a new homework. We'll give you a weekend off. We'll see you next Friday.